Hello, Year 2. In our maths lesson today, we're going to be adding 2-digit and 1-digit numbers. But before we begin, we're going to do some of our fluency activities. So first of all, I want you to practice counting in threes from 0 to 36. Let's have a go. 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. Now see if you can have a go on your own, and then see if you can count back from 36 all the way back down to 0. Have a go at this a few times just to make sure that you've got it. Then, when you've done that, I want you to complete these questions. For an extra challenge, you could show one of the calculations as a part-whole model and maybe create a fact family for another one of the calculations. It's up to you to choose which one. Well done, Year 2. I'm sure your fluency tasks were absolutely amazing. So now our anchor task. Which one of these representations doesn't belong? I want you to have a look really carefully at the different representations on this slide and then explain why. Did you get it, Year 2? Did you notice that although all the representations show 19, the 20 frame, that's the two 10 frames with the counters, doesn't belong because it shows 12 and 7, whereas the numicon shapes and the number bead string both show 10 and 9 to make 19. Right, Year 2. Before we move on to the main part of our lesson, we're just going to revise some of the vocabulary that we might use. We're going to use words like tens and ones. A two-digit number has tens and ones. We're going to use words like partition, and that means to split or to separate our number into smaller parts. So in the example, you can see 25 is split into a 20 and a 5, two tens and 5 ones. But you can also partition smaller numbers. So can you see how in the picture 3 has been partitioned into a 2 and a 1? We're going to use words like crossing or bridging 10. That just means we're going to be crossing over a number ending in 0 when we're adding. So 17 add 5 is 22. 20 is our tens number and we're jumping past that. We're going to use words like efficient, and efficient just means working in a way without wasting time, finding the best way to solve calculation, and obviously the word calculation, which just means working out the answer to a maths problem. So, before we look at the main part of our lesson, I want you to recap something we did last week. I want you to write out your number bonds to 10 in an ordered list, just like we did last week. Now, use what you know about your number bonds to 10 to complete the sequence on the right. I've done the first two for you, so that's 30 add 10 is 40 and 31 add 9 is 40. After you've done that, see if you can have a go at creating your own sequence. Your challenge is, can you explain the link between 31 add 9 is 40 and 1 add 9 is 10? What's the same? What's different? So here are our answers. Hope you got them all. I'm sure you did. Did you notice any patterns? Can you see what happens to the numbers in the left-hand column and the numbers in the centre column? Can you see how I've used my number bonds to complete the sequence? So if I know that 1 add 9 is 10, I also know that 31 add 9 is 40 because there's a 1 and a 9 in that number in the ones place. And 1 and 9 I know makes a new 10. So 10 and 40 are also both multiples of 10. So in today's lesson, you are going to be adding a two-digit number and a one-digit number. You'll use partitioning to help you add the numbers that cross the tens boundary. So just remind ourselves, what does partitioning mean? Have a think. Tell your grown-up. Do you remember that partitioning means splitting a number into smaller parts? Now our bonds to 10 are examples of partitioning because each pair makes 10. Your little challenge is, can you write out all the pairs of numbers that make 6? And to make it a little bit harder, can you write them as an ordered list? Right, are you ready to look at our first activity? Now, our first activity, we're not going to be partitioning, we're just going to be jumping on in ones just to warm us up. So, I want to calculate the answer to 17 plus 5. I want you to put the larger number in your head and count on by the smaller number. So that means I want you to start at 17 and count on 5. I've drawn a number line to help, so can you see my number line? I've put 17 at the start, and then I've made 5 jumps, and each jump's going to be worth 1. So let's see what happens when I add 1 each time. 17 add 1 is 18, 18 add 1 is 19, 19 add 1 is 20, 20 add 1 is 21, and 21 add 1 is 22. I've made 5 jumps of 1, so 17 add 5 gets me to 22. Let's have another go. Let's try 16 add 6. So, again, put the larger number in your head and count on the smaller number. So I want you to start at 16 and count on 6, making jumps of 1. I've drawn it on a number line to help you. Let's see what happens when we count on. So 16 plus 1 is 17, add on another one is 18, add on another one is 19, add on another one is 20, one more gets me to 21, and add on the final one, that gets me to 22. So 16 add 6 is 22. Have a look at my number line. Can you see how I've made each jump touch the number on the number line? It's really important that you do that when you're drawing a number line. It helps you not to make mistakes. So now I've got a little task for you. I want you to solve these calculations by jumping on in ones. I want you to draw a number line and show each jump of 1. For a challenge, show a fact family for 3 of the calculations. Okay, so here are the answers. I hope you got on okay. Did you draw your number line? Did you show each jump? So that was jumping on in ones. But there might be a better way of doing it, a more efficient way of doing it. So can we use our number bonds to solve the additions more efficiently? Let's have a look at 17 add 5 again. We can partition 5 into a 3 and a 2 and use this to jump on the number line in 2 jumps to bridge the 10. So can you see what I've done here? I've done 17 add 3 gets me to 20, and then 20 add 2 gets me to 22. So I've partitioned my 5 into 3 and 2 to make my addition more efficient. So 17 add 3 is 20, and 20 add 2 is 22. So 17 add 5 becomes 22. My 5 became a 3 and a 2 just to make everything a little bit easier. So let's have a look at another example. I'm going to slow it down a little bit and do it stage by stage for you. So we're going to see if we can solve 16 and 6 in just 2 jumps. So I've drawn my number line and I've put 16 at the start, and I've actually drawn my 2 jumps in, so I know that I'm going to make 2 jumps. So first of all, I've got to work out what's the next multiple of 10 after 16. And that's the next number ending in 0. So let me think. I think that might be 20. Let me check on 100 square. You can do that if you want. But yes, I think it's definitely 20. So I'm going to add 20 onto my number line. So my first jump is going to get me from 16 up to 20. So how many of my 6 ones do I need to use to jump from 16 to 20? Okay, let me think. Now, I know that 6 add 4 is 10. So 16 add 4 must be 20. So I need to use 4 of my 6 ones to make the jump to 20. Let's add those 4 on. Yes, 16 add 4 gets me to 20. Now I have 2 out of my 6 ones left. So I need to add those on to find the total of 16 add 6. So let's see what happens. So I've added my other 2 on, and I've got to 22. Can you see how I've solved 16 add 6 by partitioning the 6 into 4 and 2, then calculating 16 add 4, which is the same as 20, then calculating 20 add 2 to find the total of 22. 16 add 4 is 20, 20 add 2, it's 22, so 16 out of 6 must be 22. Now, there's another little video for you to have a look at called Adding on a Number Line. And the link is on our remote learning page, and that will show you exactly how I did it using some manipulatives. So your task is to complete these questions. I want you to draw a number line, and I want to make sure that you only make 2 jumps and you use your number bonds to help you. Here's your task, and your challenge is to write a number story for 2 of these calculations. If you want an extra challenge, there's some more questions that you can answer. Don't forget that I'm looking to see how you've used your number bonds. For our reasoning challenge today, I want you to use these 3-digit cards, the 5, the 6 and the 7. And I want you to create a number sentence with a 2-digit number and a 1-digit number. So put the 5, the 6 and the 7 somewhere in those boxes. You can do all sorts of different combinations. How many different totals can you find? What's the smallest total? What's the largest total? Have a go and write down your answers. How many did you get year 2? Did your answers match mine? Well done, year 2. You are fantastic mathematicians. I can't wait to see your work, so don't forget to send it to me. And I will hopefully see you very, very soon. Take care. Bye.